Okay, all right, together quickly, we want to look at, this is going to be the third aspect of trigonometry. The first aspect was reduction, which you will always need. The second aspect was quadrants, which we took from grade 10 and brought in our grade 11 reduction, into it. Now, we quickly want to look at proving identities. Now, when it comes to proving identities, it's going to be very basic in grade 11. Proving identities. So let's just quickly write. Please feel free to ask questions. You are allowed to just unmute and let me know. All right. So we are going to say proving identities. Now we are going to use two principal identities that we are going to use. Two principal identities which we spoke about, but let's re-emphasize them. Number one, tan theta is sine theta over cos theta. We mentioned this, we used it. Sine theta over cos theta will be equal to tan theta. So that's one principal identity. It's in your notes already, but please let's just rewrite it and I'll give you the steps quickly. Now, from here, we can also infer that 1 over tan theta, the reciprocal, will be cos theta over sine theta. That is the reciprocal. So if I see cos theta over sine theta, then I know it is 1 over tan theta. And the second one is sine squared theta plus cos squared theta will be equal to 1. And from here, we can say that sine squared theta is 1 minus cos squared theta. And we also mentioned that this can be written as dots because we are proving identities that will be required. So 1 plus cos theta, 1 minus cos theta. Difference of two squares. The same way from the original one, cos squared theta is 1 minus sine squared theta, also having two brackets as dots, 1 plus sine theta, 1 minus. Now, these are principal identities that we are going to use. Okay. Now, the next thing would be, how do we prove identities? The how. The how. Number one, identify the identities and change them to simpler form. To simpler form, or vice versa as required. Identify the identities, change them into simpler forms, or vice versa as required. We would see what the question would look like, and that will guide us into which one we are changing, which one we are leaving, and all of that. Number two. Simplify the LHS, meaning the left hand side or the right hand side. But hint, start from the complex side. That's always the easiest. So if the left-hand side is more complex, start from the left-hand side. If the right-hand side is more complex, start from the right-hand side. Number 3, you are allowed to simplify both sides simultaneously until you arrive at a common simplified state. Please do not solve. That is, simplify each side independently. You are allowed to simplify both sides simultaneously, which means at the same time, until you arrive at a common simplified state. Please do not solve. Don't tell me you are moving something from the left-hand side to the right-hand side. Don't tell me we are cross-multiplying. That is not allowed. We are not solving. So simplify each side independently. Work on the left side till you get to a point. Work on the right-hand side until you get to the same point as the left-hand side. And we can stop there. Are we okay with those steps, please? I hope we are okay with those little steps. Very, very important. In grade 12, we are going to add a few more identities, which makes it more interesting. Are we okay? Can I move on to the next page, please? Can I move on to the next page? I'm going to be needing your thumbs up, thumbs down as a quick way of responding as I'm checking with you whether we are going to be okay or not, whether you want me to re-explain. All right. Yes, Ashudia, talk to me. Was that a mistake? You wanted to put your hands, a thumbs up, and you put your hands up? Okay. All right, thank you, Alima, for sending a quick picture there. Smart enough. All right, let me just add one more thing and then we get into examples. It's quite straightforward. Number 4, apply rules of algebra. Very, very important. We're still going to be respecting that. Number 5, for fractions. So when I say apply rules of algebra, anything you cannot do in algebra, you cannot do here, please. There are certain things we cannot cancel out in certain places, please. Let's take note. For fractions, I like to use DDD, which is diagonal. It's always quite simple. And denominator to simplify. And unfortunately, there are no calculators here. A over B plus C over D. I know we can use LCD, but I just want us to use something a bit more simpler, more friendly. And that makes it very, very easy to deal with. And what do I mean by diagonal? I am going to multiply from my left to the right. So I'm going to multiply A times D, then B times C, then B times D, my denominator. So this should give me AD plus BC over. All right. We want to start quickly. Guys, my aim is to look at as many questions as this time frame would allow us. So I'm going to do the first one, allow you to try the second, and just and on like that. Please let us ask, let us engage. Are we ready for questions? Are we ready for questions? So these are the little notes, and that would be it. Okay, so here's my first one. Look at that. Prove the identity sine theta minus tan theta multiplied by cos squared theta, blah, 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 equals to tan theta. Now, already I can see a complex side and a simple side. I hope you agree with me. Which side do you think is more complex? Is it the left-hand side or the right-hand side? I want to see if you can identify which looks a bit heavy. Someone, either you unmute, you talk to me, or you type. Which one do you think is more complex? I'm not saying do it. I will do it for you. But what do you think? I need someone's response, someone who's not sleeping. Thank you, Asim. The left-hand side. All right, answers are coming now. I shall the left-hand side. Beautiful. So the left-hand side is more complex. Okay, and I told you, what do you do? Identify the identities. Now, the quick identity that I see here is, look at this. I'm seeing this. That's an identity. And also, look at what the examiner wants me to get. The examiner wants me to get tan theta. Put this at the back of your mind that if I can arrive at sine theta over cos theta, then I will be done. 4 marks. Let's see. All right. The aim is to get to sine theta over cos theta. So let's start from the left-hand side. LHS. Please write neatly. Sine theta minus, what is tan theta? It is sine theta over cos theta, right? Now, do you notice we have a dot there, which means we are multiplying. I can quickly write this one as a fraction. Okay. Let's see where we're going to get to. Let's use white. We have that. Okay. What do you notice? I am seeing a 1 and I'm also seeing a sine squared theta. Don't forget what my 1 and my sine squared theta will be. Okay, let's try something. I could say that minus is very important. Minus, okay. For somebody who's seen this, I want to work with the simplest idea. 1 is that. All right, plus, okay, let's see. Are we okay? Do you notice what I did? I'm trying to work very basic here as our first example. Please give me a thumbs up if you are okay with what I did. I have changed 2 things. I changed my tan theta and I also changed 1. Please bracket there because of the minus. All right. Do you notice that this cos theta can actually take out 1 there by laws of exponents? I hope that makes sense because what I have there, when I say cos squared theta, is cos theta, and I have sine theta over cos theta. Do you notice that? Okay. Now, so what do I have? Sine theta minus, check, sine theta multiplied by cos theta, or we can actually take out the brackets and multiply straight. That will be sine theta cos theta over, let's simplify the denominator now. Oh, I want white. Let's simplify that. What would that be? Okay, I'll have cos theta. What happens there? Expand minus sine squared theta minus cos squared theta plus, oh, beautiful maths. What do you notice here? Negative sine squared theta plus sine squared theta would actually cancel out each other. So let's write what we have left. We have sine theta minus sine theta cos theta over, let's write it out, over, what do we have left? Cos theta minus, okay. Are we together so far? I hope I haven't lost anybody. We are almost at the final end. Talk to me. Give me a thumbs up. Give me a thumbs up quickly if you're okay. Let's see what's happening to my network. Are you guys still there? I don't know, I just lost network here. Let me check my main computer. 1 second, what's happening? Okay, sorry, there was just a network glitch there. We are still in class and we should be back online now. All right, guys, are we all back? Can you see my screen and can you hear me? Let me know. Can you see my screen? Can I get someone to respond? Are we back online? Can you see me? Hi guys, can you hear me now? And can you see my screen? So it's just a little glitch. I should show the 4th and 5th point quickly. Somebody's asking for that. Halima, here you go. Are you screenshotting quickly? All right. I'm moving now quickly. Lovely, thank you. All right. Now, if you notice the top and the bottom, you would notice quickly that sine theta is common there. Oh, also cos theta is common. Let's factorize. We will see what that will lead us to. So if I pull out a sine theta, what do I have left? 1 minus cos theta. Okay, over what's common at the denominator? Cos theta. Again, 1 minus. You see, there are two cos, is cos theta times cos theta. If I take out 1, I am left with cos theta. I told you, apply your knowledge of basic algebra. And look at where we are. That whole bracket will cancel that whole bracket, and we are left with sine theta over cos theta, and that is tan theta. Please let me know quickly. We go for the next one. Are we good? Are we good? Please, you can take a screenshot of this as well. Thank you, Alima. Are we okay, guys? It's just simplifying. You're factorizing, you know. That's the algebra that I said. We apply our knowledge of algebra. So if I factorize, again, for somebody who's lost, if I take out the sine theta, I'm left with 1. Take out the sine theta, I'm left with cos theta. So it's 1 minus cos theta. And if I look at this, let me use a green pen here. What does this mean? This means cos theta multiplied by cos theta. That's what we're looking at. All right? So if I pull out a cos theta, which is common, look at what I'm left with. I'm left with 1 minus cos theta. Those two would then divide each other to give us 1, 1. And we said sine theta over cos theta is 10. All right, here's another one. Oh, this one is a fraction. Again, the left-hand side is more complex. And because it's a fraction, I'm going to go with diagonal denominator. Let's run through. All right, if I'm multiplying, I'm starting from the left-hand side. Let's see where this will take us. I will be saying 1 multiplied by 1 plus sine theta. It's just a simpler way of dealing with fractions. So what have I done here? I have taken this, let me use red. I have taken this and multiplied, don't worry about the sign, 1 times 1 plus sine theta. Now my negative sign is in between, so I'm going to put a minus, and then I'll multiply across cos theta times cos theta. I'm going to do like this first, so that everyone can see and follow through. All right? Over, now I multiply the denominator, cos theta into 1. It will never fail you when it comes to fractions. Diagonal denominator. We can then simplify. If you multiply that, I'll have 1 plus sine theta minus cos squared theta over, you know what? I'm going to leave this one for now. You see, once we start doing it, you would realize. I'll tell you why I'm leaving it. Remember, the examiner wants me to get tan theta, which is sine theta over. And I'm already seeing a cos theta here. Do you see that? Which is my denominator. The idea is to get rid of this guy. And just like the first one, I need to find this thing. I need to find it up here. But let's see. Now, there are two ways here. Somebody else can change 1, and somebody else can change 1 minus. I don't know if you see that. There are two ways. I could take my 1 and write sine squared theta plus cos squared theta. Or, look at this. 1 minus cos squared theta. Do we remember what that is? 1 minus cos squared theta. Check. 1 minus cos squared theta. Do you see that? What is that? Sine. I want you to start seeing that. Have eyes for that. 1 minus cos squared is sine squared. I don't want us to always change the 1. We must now start moving. Okay, so this would become sine theta. 1 minus cos squared is sine squared. Let's keep that denominator. Similar to where we came from, the first question. What is common in the numerator? Sine theta is common. What are we going to be left with? 1 plus. It's a squared theta, so we take 1 out of that. And look at where we are. Oh, beautiful. Look at where we are. If you didn't see it, in your first step, you'll still get it. It's just going to take longer. Sine theta over cos theta. And what is that? Is it making sense to you? So every time you change an identity, you'll be getting 1 mark. Let's see. If I were to put ticks here, for simplifying up to this point, I'll get 1 mark. Then for bringing in sine squared, I'll get 1 mark there. All right. For factorizing, I'll get 1 mark. For getting sine theta over cos theta, I'll get 1 mark. And then for tan theta, I'll get 1 mark. Keep simplifying. That's the whole idea. Keep on simplifying. Please, is there anyone who is lost? You want to ask me a question? Remember, we could also have taken this 1 and written it as what? Sine squared theta plus, and that will cancel out that, leaving me with sine squared theta plus sine theta. All right, another 5 marks in the bag. Let's move quickly. Okay, I want you to try this. Well, I know somebody's going to say, wah, wah, wah. Please try it. There's a square root there, beautiful. We're supposed to get 1. I'll give you 4 minutes. Give me an attempt. Try. There we go, you have 5 minutes. Give me an attempt. Start from the complex side. Just do maths, don't do magic, okay? Don't do magic, do maths. Don't get a 0. Change whatever you can change. Change tan theta. Use fractions. Let me give you a hint. I'll give you a little hint. This is 1 over 1. Work with that. DDD. You'll get an answer. You'll be shocked at yourself now getting an answer. Give me a thumbs up if you were able to get somewhere and you got it. Just give it a trial. Write out neatly so that your algebra is well done. Okay, let's mark. Were you able to get something out of it? Were you able to get, I'm sure you did something. Yes, Alima, lovely. Okay. Or is it Amida? All right. Thank you, Tamina. Thank you, Wasim. I saw a lot of people giving me thumbs up. Aisha, lovely. Zamir, well done. Yes, beautiful. Lord Gat. Yes, Raif. Are you trying to ask a question, or you're giving me thumbs up that it was okay? Okay, let's check. What would I have done? All right, obviously starting from the left-hand side. What is tan theta? I'll have changed it to sine theta over cos theta. And I have my big umbrella root. And I told you it's 1 over 1 there, right? So which I can do DDD 1 times 1, 1 minus sine squared theta over denominator. I hope this makes sense, please. Did you guys get what did you get that? It is 1 over sine squared theta minus 1 over 1. So if I do my first diagonal, 1 times 1 is 1. 1 times sine squared theta is sine squared theta, and sine squared theta, just always. That will never fail you. Now, I don't know if you see this quickly. Let's see. Look at this. I don't know if you see something there. What do you see there? I don't know if you see something there. Sine theta over, so you need to keep those identities close by. That is actually cos squared theta. Oh, beautiful. Sine squared. Ah, lovely. So I have sine theta. Now, under rules of surds, because we can find the square root of cos squared, if I tell you what's the square root of 9 over 4, if you check, what's the square root of 9? It's 3. What's the square root of 4? It's 2. It's 3 over 2. All right? So what is the square root of cos squared? It is actually cos theta. What is the square root of sine squared? Guys, we can find the square root because it's not a plus or minus. Guys, you can't tell me this one is 3 minus 2, which is 1. That would be wrong. You can't say the square root of 9 is 3 and the square root of... No, there's a minus there. We don't do that. We only do that. I gave you laws of exponents. All right? We did that, and even laws of surds. We can only do that when we multiply on where we divide. Oh, beautiful here. What do you notice? Do you know things canceling out? Cos theta 1, sine theta. Check that. Simple. And your answer is 1. We're done. Not bad. Not bad. Just following the rule. Basic algebra rules, and we're good. All right, did we get it right? Talk to me. Did we get it right? Did we get it right? Okay. If you can send a picture of this to be nice quickly, so you guys can grab a picture. Tazib, talk to me. What's up? Are we okay there? Okay, where did I lose you? Where did I lose you? Remember, we're using diagonal denominator. 1 times 1 is 1. That's where this one came from. Sine squared theta times 1. That's where that came from. And the denominator, we have that. Keeping my big umbrella. And 1 minus, don't forget that you can, this is where the challenge might be. If you cannot see this, you have to change this. Look at that. Sine squared theta plus cos squared theta minus, but it's a longer step. Do you see I have cos squared theta? All right? I have cos squared theta, and that will give me that. But what is the square root of, there are so many ways of moving from here, so many ways. What is the square root of cos squared theta? It is cos theta. What is the square root of sine squared theta? It is sine theta, and I'm done. Let me show you another way from that particular point. I see there are about 3 ways there. All right, I'm going to show you another option. Look at what I have. Sine theta over cos theta. I could easily say this is 1 over. Remember the identity? Oh, look at that. Beautiful. And change this back. What is sine theta over cos theta? It is tan theta times square root of 1 is 1. And square root of tan squared theta is tan theta. Since I'm multiplying, check that. I'll have 1. Tazib, are you okay? All right. Okay, beautiful. And that's how we get work done. So there are so many ways. So many ways. I need you to be fast in identifying that. It's going to take a few exercises, but once you are able to identify that as this, you're going to cut a lot of steps instead of always changing 1. Okay. All right. Try this for me, everybody. It's 4 marks. Let's go. Let's try it. Let's try. There we go. Oh, let's put some timer here. Let's put some timer. 5 marks. 5 minutes. 4 marks, 5 minutes. Let's try it quickly. Hi guys, were you able to get me an answer here? Oh, what did I do to my mic? Can you guys still hear me? Can you guys hear me? Lovely. I don't know what I did to my mic. It just changed colors. All right. Were you able to get an answer? Let's see. Oh, people are saying yes. Okay. What would I have done? Again, I would have started from the left-hand side. Let's see. Again, do you notice this is a very common question in grade 11? We are looking for sine theta over cos theta. All right, from the top there quickly, my first step, I already have my sine theta. 1 minus, oh, beautiful, over, check this, cos theta minus, oh, everybody look at that. 1 minus sine squared theta. Hold on. Look at this. Sine squared theta plus cos squared theta equals to 1. If I move this over, I'll have cos squared theta as 1 minus sine. Oh, beautiful. Look at maths. Oh, wow, what a wow. What's common? Do you notice this is kind of repeated? Over cos theta is common. 1 minus, oh, we are done. Why did I give you 4 minutes? I didn't know this was so simple. And what's your answer? Ah, sweet. Are we done, everybody? Are we okay with that? We okay? Lovely. Okay, let me see what I have. Somebody take a picture. Oh, there's another one. All right. We're good. No questions? Just basic algebra will just save the day. Thank you, Halima. Here's another one. Don't stress. Just do what I ask you to do. The same principle. That's maths. Whether you're driving a truck or you're driving a trailer, it's the same principle of driving. Come. 5 marks. It's a fraction, please. It's a fraction on the left-hand side. What do? Diagonal, denominator. Write it out explicitly so that you can work. Any luck? Any luck, guys? Were you able to win through? All right, let's see. Let's see. What would I do? I would use my DDD. It's a fraction. Guys, the reason we repeat so many examples is the principles are the same. So if I multiply, I would have 1 plus sine theta multiplied with the one at the bottom. 1. Please don't forget D, diagonal. If you forget these little principles, we're going to have a challenge there. Now, there's a minus. Then we go for the second one. And that's how we deal with fractions. Always quite kind of easy. Multiply that. First one. There's a minus. That's the minus. Multiply that. What would that be? That would be 1 minus sine theta. 1 minus sine theta. And then we deal with the denominator. 1 minus. And I think if you just do this, the whole answer would be done if you do it nicely. All right, what do you notice here? We are foiling. All right, that would give you 1 plus 2 sine theta plus sine. I hope you all know what I did. Let's explain. 1 times 1 is 1. Sine theta there. Then another sine theta, which gives me 2 sine theta. So we're foiling. All right? If I do the same thing here, bearing in mind that I have a bracket, 1 times 1 is 1 minus 2 sine theta plus sine squared theta. I hope I haven't lost anyone. Oh, look at this. Difference of 2 squares. 1 minus sine squared theta. Please let me know if I just displaced you there, or give me a thumbs up if you are okay with that step. I only did my foiling here. 1 times 1 minus sine theta minus sine theta positive, because negative times negative. Okay, let's simplify. As long as you're not doing magic, you will see maths very, very friendly. Look at this. Now expand. Minus 1. Negative, negative is positive. And then minus sine squared theta. Look at what I am proving. I am proving a cos theta at the bottom. And that should be cos squared theta. So you have to know your identities and change them as quickly as possible. Now, what do you notice? Let's see. Do you notice there's a 1 here, minus 1, which would give me 0. Sine squared theta, let me use a yellow there. Sine squared theta minus sine squared theta would give me a 0. What am I left with? I'm actually left with 4 sine theta over cos squared theta. But I want a 10. Oh, look at this. Cos theta, cos theta. And what is, I'm trying to get this to, let me see if I can get that. All right, look at this. What is sine theta over cos theta? Do you notice that's 10? Done. Maths is no magic at all. Did that make sense to you? Is there anywhere you are lost? Please let me know. We're good? We are good? Okay, let's see if I have another one. I'm just trying to do as many as possible. All right. The girls are sharing the pictures on their groups, which is nice. Oh, okay. These are other questions, but can I quickly try something with you? Can you do this one for me? I want to handwrite this one. Prove that 1 plus 2 sine theta cos theta is cos theta plus sine theta squared. This one should be 3 minutes. 3 minutes. Did you manage to get an answer for me? There's something I'm looking for here. $20 more. Okay, I think I will change the 1. What is 1? Sine squared theta plus cos squared theta. I want to do something here. Now, that's a trinomial. How do I know it's a trinomial? Check. I could write this like this. I'm going to do this in 2 ways. Okay, I want to show you how to quickly deal with a trinomial. Look at this. If I have this plus 1, watch that. Instantly, I know that I can open 2 brackets, x, x, and my factors are plus 1. Watch that. All right. Now, mathematically, if I introduce a y here, watch that, this then would be a y squared. You know what I'm going to do? I'll change this to y, and I'll change this to y. Let me repeat what I just did. So I originally do not have a y, okay, which we are all used to here. If I put a y here, then this will be a y squared. Automatically, this becomes a y. So that when I expand, x times x is x squared, x times y is xy, y times x is xy, and that will give me y squared. and I have x squared, check, 2xy. And that's exactly what I have here, sine squared theta. So if I want sine squared theta, I'll say sine theta multiplied by sine theta. If I want cos squared, it will be cos theta multiplied by cos squared. Oh, beautiful. And what do you notice? Do you notice that is simply sine, since it's the same bracket? Oh, we are done. Lovely. Or, let me show you something else. Or, I'll keep that first line, sine squared theta plus 2 sine theta cos theta. Now, let me simplify the right-hand side. Oh, no, I missed something there. I missed the cos squared. All right? Plus, look at this. Now, if I simplify the right-hand side by foiling, what is cos theta times cos theta? It is cos squared theta. You know how to foil. Sine theta cos theta multiplied by 2 sine theta. Oh, do you notice I did the left-hand side separately, did the right-hand side separately, and they are both equal. So I'll say my left-hand side is equal to the right-hand side. Did that make sense? I simplified the left-hand side differently. I simplified the right-hand side independently. I got to the same spot where they are both equal, and I'm done. Did that make sense? Did that make sense? Please use your file, look for more questions. I'm not sure I picked anything from the file. I was speaking from some past papers. I'm sure you have a few in the file that you can practice. When we meet each other again tomorrow, if there's anything that you would like me to do, please let me know you came across a difficulty. Before we log off, I just want to do one of these questions. Many of us are still struggling, so just 2 questions quickly. These are the main things we've done. Many of us are still struggling with that. Can you please try 3.1.1 for me? Just to make sure we keep revising that, please, everybody. 3.1.1. I'm giving you just 3 minutes. I need you to be able to see, what am I doing here? Am I nodding my head? Am I shaking my head? Am I changing the trig ratio? Quickly, everybody. Do you know how to reduce? We're finishing up now with just 12 marks. Okay, guys, done here. This shouldn't take us so long. It's just for us to remember the principles of reduction that I taught you. Sine 90 minus x. Am I changing the trig ratio? Yes. Remember, we're nodding our head. And is it a positive or a negative? Sine, we just put 90 minus 1. It's a positive. Beautiful. And I'm changing. So that becomes what? Cos x over 360. Are we changing? We are shaking our head saying, no, we are not changing. We put that in a calculator to check the sign, and it's a negative. And since we are not changing, negative sine theta divided by 10x minus 180. 180 again, we are not changing. But can I put that in? Please look at what I'm putting in the calculator. Some of us are still, doing a whole lot of mixed masala things. All right, and we're not cooking here. Okay, so 1 minus 180, check that. It's a positive, and 180 I am not changing. Lovely. So it becomes a positive. Oh, I wrote theta instead of x. Oh, sweet. All right. According to the rules of algebra, negative. Now, this is the same thing as saying divided by what? Sine x over. I'm sure you know that, right? Lovely. According to the rule of algebra, we keep, we flip, and we change the sign. You remember that? Okay. Top times top will give us cos squared x over negative there. Oh, what will this give us? What is cos squared over sine squared x? That is 1 over tan squared. Is this what you got, everybody? Is that what we got? We need to make sure that this is sorted. We don't want to come back to this and make mistakes. So if you are struggling with this, please look for more of these questions and deal with them. Remember the principles. You are either shaking your head or you are nodding your head. And that's the whole idea. Again, where do I shake my head? 0 degrees, 90 degrees, 180 degrees, just to remind us, 270 and 360. I used to have a picture of a head nod and a head shake. Let me see if I can get it. Did I download? It's not here. I think I cropped it. Okay. But please, and here you're saying, if you're shaking your head, no, don't change. But if you are nodding your head, you're saying yes. And that's it. Okay. Finally, no, not this one. This one. Okay, I'm going to ask you to take a picture of this. Very interesting. But I wanted to give me this finally for today. 7 marks now. I want us to put that 7 marks in the bag quickly without the use of a calculator. Remember the drill. You don't show them that you are using, but you quickly use. Guys, I want us to finish. So 4 minutes here. 4 minutes, let me say 30 seconds for 7 marks. That's cheap 7 marks in your bag. Cheap, 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 cheap. And then I'll say good night to you all now. All right, let's mark this quickly and then we wrap it up. Tan 205. Now, if you know what to do, it doesn't take so long. These are numbers, and I taught you how to do that. Tan 205 equals to, this is where you use your shift tan answer, and then you get tan 25. Lovely. So my first one is in tan 25. Multiplied by cos 315. Sweet again. You just quickly, pa, 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 pa. Each of them is 5 seconds. All right. Shift cos answer 45. All right, beautiful. I have cos 45 degrees. Sine 135. If you do this nicely, you'll get sine 45 because we are in the second quadrant. All right, shift sine answer 45. We're done with the third one. By the way, I'm sitting on 3 marks already. Sine 210. All right, I'm in the third quadrant and sine is negative, which is going to be giving me negative 30 because it's 180 plus 30. But let's see, am I correct? Negative 30, shift sine answer, boom, negative sine 30. I'm on mark number 4. Cos 150, that is in the second quadrant. It's going to refuse on your calculator. Cos 150 equals to, it's going to refuse 150. What do? Minus 180, negative 30. And then tan 25, I don't have to do anything there because that angle is smaller than 90. All right. Oh, beautiful. Beautiful here. Let's see. Oh, there's nothing much to do here other than that and that taking themselves out. The rest are special angles. Cos 45 is root 2 over 2. If you don't remember, I told you, nothing wrong with using your calculator. There's a mark here. All right. Over. Now, negative times negative will give me a positive. And what is sine 30? You must change that. It is half. And cos 30 is root 3 over 2. Okay, let's put the negatives first. And then we simplify. So the negatives are in. Now, when you simplify, you can use your calculator, type everything in. But let's do a bit of maths without calculator. Root 2 times root 2 would give you 2. And that would give you 4. Divided by negative times negative is negative. 1 times root 3 would give you root 3. And 2 times 2 would give you 4. All right, according to the rule of maths, 2 over 4 times 4 over root 3. Ta. All right, check. Your calculator will not allow you to leave it like that. What do? We rationalize. Do you remember what we do? Multiply that. What do you have? 2 root 3. Did you get that? Did you get that? Talk to me quickly. And my good learners, that will be it for this morning. Thank you for the extra 21 minutes that you gave me. But I have questions for you, please. Somebody should take it from the girls group and somebody else pictures from the boys group. Thank you. The girls have been taking pictures, screenshots all along. Well done. Please take a picture of this 5 marks. I want you to try this. You have the whole day. Boys, please take a picture as well. It's very important. I think I have about 3 questions I wanted to take pictures of. All right, you should be done with a screenshot there. That's 1. That's 2. Did we get the second one in? And I think the last one is that. 7 marks. Please just practice them. They will be of good importance. I want you to practice them and use them well. All right. Have a lovely, lovely one, everybody. And goodbye. All right, guys, you are free to sign out. We will mark this when we meet each other again. Bye, everybody.